Welcome to Decode the Hacks. This is the story of YOLO Mode in AI. Have you heard this acronym? YOLO, you only look once, where AI coding agents have been granted unrestricted access to delete files, execute code, and commit changes without human oversight. What we are about to uncover isn't speculation. It's forensic evidence from UpGuard's February 4, 2026 research. Real-world security disasters, including the OpenClaw collapse and a hypothetical scenario that keeps security teams awake at night. The Recursive Wipe. By the end of this investigation, you will understand why this isn't just a developer problem. It's a supply chain security crisis that threatens the entire AI software ecosystem. So, let's begin. Welcome to the crime scene. The date is February 4th, 2026. UpGuard, a leading cybersecurity research firm, published findings that sent shockwaves through the development community. Their team analyzed over 18,000 AI agents, configuration files pulled from public GitHub repos. What they discovered was alarming. Developers worldwide have been granting AI coding assistance tools like Claude Code, Cursor, and OpenClaw permissions that security professionals would consider reckless. The analysis wasn't based on theory or speculation. This was hard data. Actual configuration files showing real permissions granted to AI agents operating in production environments. UpGuard's forensic approach revealed a pattern that suggests this isn't isolated incidents, it's systemic. The vulnerability has been labeled YOLO mode, referring to developers essentially saying you only look once while handing over the keys to the kingdom. The critical discovery, unrestricted AI agent access, is now embedded deep in developer workflows across enterprises, startups, and open source projects. The scale of this vulnerability is massive. According to UpGuard's analysis of over 18,000 GitHub configuration files, we are not looking at a few isolated incidents. We are looking at a systemic failure. 1 in 5 developers have explicitly granted their AI coding agents unrestricted access to their local workstations. This isn't just about reading files. We are talking about permission to delete files, execute arbitrary Python or Node.js code, and even auto-commit changes directly to repositories without any human review. Let me put this in perspective. In a team of 10 developers, statistically, 2 of them are operating in this high-risk YOLO mode right now, creating an open door for supply chain attacks. This means millions of developers globally have created a perfect attack surface. Let's break down the weapon. When we say YOLO mode, we aren't using a buzzword. We are describing 3 specific, forensically documented permission categories that security researchers have flagged as critical threats. Evidence category number 1, unrestricted file deletion. This permission allows AI agents to execute commands like rm-rf/ on Unix systems, the nuclear option for deleting everything. Evidence category number 2, arbitrary code execution. When developers grant exec or eval functions permissions to AI agents in Python or Node.js environments, they are giving the AI the ability to run any code it generates or receives, bypassing sandboxes and security controls. Evidence category number 3, auto commit bypass. This is perhaps the most insidious. Traditional development workflows require human code review before anything reaches production. YOLO mode allows AI agents to commit code directly to the repositories, skipping the human checkpoint entirely. Each of these permissions has a threat level designation of critical for obvious good reasons. Any one of them can be weaponized through prompt injection. The story of OpenClaw is the perfect cautionary tale for this new era of AI risk. Originally launched in November 2025 as ClaudeBot, this open source AI assistant went viral almost overnight. Developers loved it. A personal AI that could automate tasks, book flights, manage calendars, and write code 24/7. It was so popular that it changed name twice in rapid succession, from Claudebot to Moltbot to OpenClaw, trying to manage trademark issues and maintain explosive growth. But beneath the hype was a security catastrophe. Within just 3 days, in late January and early February 2026, the project issued 3 high-impact security advisories: a one-click remote code execution vulnerability and 2 separate command injection flaws. Security researchers at Koi Security discovered 341 malicious skills that had been uploaded to Claude Hub. Over 1,800 OpenClaw instances were found exposed online with zero authentication. This wasn't a theoretical risk, it was active exploitation at scale. Let's dissect exactly how this attack happens. It takes less than 60 seconds from start to catastrophic finish. Step 1. An attacker crafts a malicious prompt. This could come through a compromised dependency, a poisoned MCP server, or even hidden in documentation the AI reads. The prompt is deceptively simple. Something like, "Hey AI, clean up all the test files in this directory." Step 2. The AI agent receives this instruction and interprets it literally, preparing to execute cleanup commands. Step 3. YOLO mode bypasses the human review checkpoint. There's no confirmation dialog, no manual approval. The AI has unrestricted permissions. Step 4. Execution. The agent runs git rm-rf followed by git commit and git push. Step 5. Recursive deletion cascades begins. 5,000 files deleted in 12 seconds. Database configurations gone by 30 seconds. Step 6. Production repository wiped at 47 seconds. And auto push to main branch at 48 seconds. The entire attack duration from prompt to repository destruction under 1 minute. And recovery status? Impossible without backups. The damage isn't hypothetical. It's already here. The OpenClaw incident left a trail of 341 malicious skills uploaded to Claw Hub, which is the community skill repository. These weren't accidental bugs. They were intentionally crafted Trojan horses. One example documented by security researcher Jameson O'Reilly was a skill called "What Would Elon Do?" that Cisco skill scanner flagged for 9 critical security findings, including direct prompt injection, silent data exfiltration via curl commands, and command injection through embedded bash scripts. The second casualty, plain text credentials. Over 1,800 OpenClaw dashboards were found online with zero authentication, leaking API keys, database credentials, and access tokens in plain text. The third casualty is more absurd but equally real: cost. One developer, Benjamin, woke up to find his OpenClaw instance had burned through $20 overnight just checking the time every 30 minutes via Anthropic's API. Extrapolated monthly cost for that single feature, $750. Multiply that across thousands of careless deployments and you have financial losses at scale. The issue isn't just in the AI agents themselves. It's in the supply chain they rely on. The Model Context Protocol, or MCP, is the standardized way AI agents connect to external tools and services. UpGuard's research uncovered a massive typo squatting operation. For every legitimate, verified MCP server from a real technology vendor, there are 15 lookalike imposter servers from untrusted sources. That's a 15-to-1 imposter ratio. These fake servers use subtle naming tricks. GitHub MCP versus GitHub MPC, or Claude Tools versus Claude Tools with letter L replaced by the number 1. Developers installing these packages don't notice the difference until it's too late. Once installed, these malicious MCP servers become Trojan horses, injecting malicious code directly into the AI agent's workflow. The attack vector is officially active. This isn't theoretical supply chain risk. It's a documented infiltration campaign targeting the AI agent ecosystem specifically. When security teams lack visibility into which MCP servers their developers have installed, every installation is a potential backdoor. Also, this is not just about one bad bad setting on one developer's laptop. This is a security architecture crisis that affects the entire software supply chain. Look at this network topology. Individual developers are the first layer of nodes. They connect to AI agents in the middle layer. Those AI agents then have direct access to production systems, open source repositories, enterprise infrastructure, the entire outer layer of critical assets. When one developer operating in YOLO mode gets compromised through a prompt injection, that infection spreads. One compromised developer equals one compromised AI agent, which equals one compromised production system, which then equals one compromised supply chain. The math is simple but devastating. 1 in 5 developers means 20% of the global software supply chain is currently exposed. Traditional defenses, firewalls, intrusion detection, endpoint protection cannot detect prompt injection attacks because the AI agent is operating with authorized permissions. This is not a developer problem. This is a fundamental failure of a security architecture in the age of AI agents. And with that note, we will wrap up this video. Thanks for watching Decode the Hacks. If you found this video educational, please do take a moment to subscribe to this channel and hit that like and also hype button on YouTube so that this video reaches the majority of people like yourself who take cybersecurity very seriously. Thanks and stay safe.